Hi everyone, today I'm going to be talking about PDMS lenses, what they are, how they work, why they're important, and how to make them. So before I start, I'd like to give a special thank you to the UC San Diego MERSEC program, specifically the Sailor Lab, for conducting research and manufacturing these lenses. And I'd also like to thank the NSF for providing funds through a grant. So let's start by talking about what PDMS lenses really are. So PDMS stands for polydimethylsiloxane, and it's a type of silicone used solely as the only component of these lenses. So in the middle picture, you can see a side view and a top view of these lenses. You can see it's kind of like spherical, and they're also very, very small. So you take these lenses and you can stick them onto your smartphone camera, and what happens is it allows your camera to focus at much shorter distances, so you can capture images much more close up, and this allows you to take in a lot of small details, and it can even magnify the images a little. So on the left side here, we have an abalone shell taken up close, so you can see the individual ridges and even dust flecks. And on the right, we have a very close-up image of a pen. And keep in mind, these are all taken with a normal smartphone. Obviously, without these lenses, your smartphone can't even get as good of quality, nearly as good of quality. So in the pen, you can see the details are so fine. You can see where the ink starts and the little ridges on the side of the pen. So overall, these lenses are just transportable and accessible things you can just stick onto your phone to make it into a kind of mini microscope. So how do they work? Well, these lenses are curved. That's what allows them to work. So anything curved that also allows light to pass through, it will kind of bend this light and refract into a single focus point. So all this light will collect at one point. And so, for example, in our eyeballs, that's what our cornea does. It takes all this light that's coming in, it combines it into one point known as the focal point, and then this focal point is now taken by our optic nerves, and our brain creates an image. So similarly, a camera lens does this. Our camera lens takes light, it focuses into the focal point, and then it captures the image. So both our eyes and the camera, there's a range of focal lengths that it can capture. So this focal length is the distance from your focal point to the surface of your lens. And our focal length depends on two things. One is the curvature of the lens itself, and one is the distance of an object. So the closer an object is to you, the shorter the focal length is. So both our eyes and our cameras, it can only capture a certain range of focal lengths. Anything outside of this will be blurry and out of focus. So the easiest way to see this is if you take a book and you place it really close to your face, let's say about an inch away, then the words will be too blurry for you to read. Similarly, if you take a camera and you put it up really close to the book, the text will not be in focus at all. So what these lenses do is it allows us to manipulate the curvature of our camera lens, because we stick it on and now they kind of compound into one new lens that has a different curvature and therefore a different range of focal lengths. And so why is this important? Well, obviously because we can't manipulate the curvature of our eyes or our cameras, right? It's unrealistic to say, oh, I'm going to change the shape of how my eyeballs are, or I'm going to replace my camera lens with something else because I want to take a picture of something closer up. So by having this easy and accessible lens I can just stick onto the camera, it becomes much more accessible to take pictures of close-up things. And so another thing that makes these lenses so special is that the curvature and therefore the focal distance can easily be adjusted of the lens, so that we can have multiple different lenses that all create a different range of focal lengths when we want to take a picture. Okay, so let's go over why these PDMS lenses have the curvature and how we can manipulate this curvature. So the PDMS originally starts out as a solution, so liquid, and all liquids have something called surface tension. Surface tension is caused by attractive forces within the molecules themselves, and this results in the liquid wanting to minimize its surface tension energy. And it does this by minimizing the surface area for a given volume. And ideally, a sphere is able to do this. So all liquids have a tendency to bunch up into a sphere. However, there are other external forces such as gravity or interactions between a liquid and the surface they sit on. So no liquid will technically be completely spherical. And back to the topic of interactions between the liquid and the material it sits on, these interactions are actually extremely important. So for example, in a lotus leaf as shown here, the way it interacts with the water droplets is it allows it to remain a spherical shape. But if you instead drop water, let's say on a marble surface, it will kind of flatten out and not have a spherical shape at all. So there are two main models used to model these effects, the interactions. We have the Wenzel model and the Cassie-Baxter model. So to summarize, both of them say that the roughness of a surface impacts the curvature of your liquid. So as you can see in the diagram, we have a liquid resting on a completely smooth solid. And then we have the liquids resting on a solid that has little bumps and little holes, and you can see that it's much more round. Regardless of if we use the Wenzel model or the Cassie-Baxter model, both of them say that this liquid will have a more spherical shape. So what we do in this lab is we take silicon, which is originally very, very smooth, and we electrochemically etch it so there's tiny holes on the surface to create this roughness that allows our PDMS lenses to have a curvature. So on the picture below on the right, you can see that's completely unetched silicon. It's just normal smooth silicon, and the PDMS solution, it goes on, it just flattens out. Now instead, we create a lot of tiny holes on the surface and it bunches up. And because we can control the amount of holes we put on our silicon, we can then control the curvature of our lens, and therefore we can control the range of focal lengths that our cameras can pick up. So why is this important? Well, beside the obvious application, if you're taking it, you're putting it on your smartphone and you can take really cool and interesting pictures, something that makes this so appealing is it's very, very easy to make. We'll go over the manufacturing process later. And it's very cheap to make. You can mass produce it easily. So for example, in the Sailor lab, we were able to produce hundreds of these lenses in the span of a few weeks. And something that I think is really cool is if you can actually integrate an optical filter into these lenses so that either filters out a light or only allows a certain wavelength of light to filter in. And this can be used in biomedical imaging. So in the pictures below, you can see these are taken of really, really small particles, probably on a micron scale. And so obviously this is very convenient to use for different medical procedures when we need to image something. And once again, this is super easy to use. You don't have to get any fancy equipment for anything. Okay, so let's talk about how they're made. So like I mentioned before, we have silicon. We can't use just a smooth silicon or a flatten out, but instead we etch it and we create tiny little holes that allows the spherical shape. And then after we put the solution on, we want to get rid of any air bubbles, because if there's air bubbles, it interferes with the way light refracts, and then we'll get blurry images. So we put them in a vacuum to remove all our air bubbles. Then we take our wafer with the drops on it, we place it into a vacuum oven, we just bake it for a little bit, we take it out, we peel off the lenses, and they're ready to use. So as you can tell, this is a very, very simple process. It's very easy, it's inexpensive, and like I said before, you can make a lot of them. For a more detailed procedure, please check out our other videos. But yeah, just in general, it's a very simple process. We can make a lot of these lenses and they're very useful. So in conclusion, these lenses are something we can put on our phones. We can put on other imaging devices to change the range of focal lengths we can pick up. So the range of distances we can capture with our camera. They're easy to use. They're very accessible, cheap. So it's a prospective option in future biomedical imaging applications. Thank you for watching, and here are my image sources.